Data preprocessing is vital for machine learning, transforming raw data into a clean, formatted state. This step enhances model accuracy and efficiency, addressing real-world data issues like noise and missing values. Understanding preprocessing is crucial before diving into dataset acquisition and further steps in building robust machine learning models. Obtaining the dataset is the initial step in data preprocessing. Datasets can be in formats like CSV, HTML, or XLSX, with CSV being popular for its simplicity. They can be sourced online or created using APIs. Proper dataset acquisition is crucial for effective data preprocessing and subsequent machine learning model development. Importing essential libraries like NumPy, Matplotlib, and pandas is crucial for data preprocessing in Python. NumPy facilitates mathematical operations, Matplotlib aids in data visualization, and pandas is key for data manipulation. These libraries streamline the preprocessing workflow, ensuring efficient handling of datasets before importing them for further analysis. Importing datasets is crucial for data preprocessing. Set the working directory and use pandas read CSV BAOs to load CSV files from local or online sources. This ensures data is ready for analysis, facilitating seamless integration into machine learning workflows. Extracting variables is essential for model training. Independent variables or features are separated from the dependent variable, the target outcome. Using pandas' iloc method, we efficiently extract these variables, ensuring the dataset is ready for further pre-processing steps like handling missing data, which is crucial for maintaining model performance. Handling missing data is crucial for model accuracy. Missing values can be managed by deletion or imputation, with imputation being more efficient. Scikit-learn's imputer class replaces missing values with the mean, ensuring data integrity. This step is essential before encoding categorical data, which requires numerical input for machine learning models. Encoding categorical data is crucial as machine learning models require numerical input. Label encoder and one-hot encoder from sklearn are used for this purpose. Dummy variables prevent false ordinal relationships in categorical data, ensuring accurate model interpretation and performance. Splitting the dataset into training and test sets is essential for model validation. Using sklearn's train test split function, we ensure the model generalizes well to unseen data. Proper splitting prevents overfitting and enhances model performance, allowing accurate predictions on new datasets. Feature scaling standardizes variables to prevent one from dominating others. Techniques like standardization and normalization are used. Sklearn's standard scaler is commonly employed for this task, ensuring all features contribute equally to the model's performance. This step is crucial for models relying on distance metrics, enhancing accuracy and efficiency. Combining preprocessing steps ensures code is comprehensive and reusable. Not all steps are necessary for every model, allowing customization. Proper preprocessing is crucial for successful machine learning model development, enhancing accuracy and efficiency. This approach allows data scientists to tailor preprocessing to specific model needs, ensuring optimal performance and adaptability across various machine learning tasks. Data preprocessing is essential for ensuring data quality and enhancing model performance. By adhering to structured preprocessing steps, data scientists can develop robust models. Effective preprocessing results in more accurate and efficient machine learning outcomes, underscoring its critical role in the success of machine learning projects.